Alright, this video is intro to probability, and it's going to go pretty fast because it's going to sum up like all the probability that you've done in the past. But there are extra resources that if you need extra help and you need to slow down, you can go check those out, and you can always ask me for help. So your learning target is I can model and solve problems using probability. Alright, so let's just talk about this, the basics. So probability is the likelihood that an event will happen. An event will happen. Alright. So, I'm not sure where you start learning probability. Maybe it's in elementary school. But I think you start doing these little tree things in middle school, if I'm not mistaken. So, here's an example. A classic probability experiment is tossing a coin. For example, if a coin is tossed 3 times, what is the probability that there will be at least 2 heads? So this is what you would have done. So here's your, this is the first time you flip it. So you could either get heads or you could get tails. And from that first heads, you could get heads or tails. Heads, tails, heads, tails. Same thing with the first tails you got. You could have gotten heads or tails after that. Then heads, tails, heads, tails. So, one coin toss, the possible outcomes are heads or tails. So that was our first row right here. And then 2 coin tosses, you could have heads and then get heads again, heads and then tails, tails and then heads, tails and then tails. So that's looking at like this combination, then this one, and then that one. So that's where I'm getting that. Alright, and then the last one, these are kind of a lot. You could get heads, 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 tails, heads, tail, heads, heads, tails, 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 heads, heads, tails, head, tails, 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 heads, tails, tails, tails. And you get that from doing this. So that's where I got heads, heads, heads. Then you could get heads, tail, heads, heads, tail, sorry. Then heads, tails, heads, heads, tails, tails. So that's where you're getting those combinations. So it's just reading down the chart. Alright, so that's how we get, when you toss a coin 3 times, you have 8 possible outcomes. Okay. So what we would do is anytime we talk about probability, it's going to look like a fraction. So, number of ways an outcome can occur, like what you want to happen will always be on top, and then on the bottom would be total possible outcomes. So you have to know how to find the total possible outcomes so that you can just count and do some stuff. So for example, look at this one. So circle the number of ways that at least 2, this is supposed to be heads, can occur. So at least 2 means you could have 2 heads or you could have 3 heads. So what we're going to do is we're just going to circle all those possibilities. So at least 2. That one would work. This one would work. This one would work. And this one. Okay. So what's the total possible outcomes? We already did that in the last, on our last page. There are 8. And then if we were going to find at least 2 heads, we would use this formula. So on top, we found that there are 4 ways out of 8 possible. And remember, that reduces to 1 over 2. So some other things you might see, sometimes they'll ask you for probability as a ratio, so like 1 to 2. Or you could have done 0.50 or 50%. So just know that everything right here, and even 4 over 8, if you didn't simplify, I would still count it. All of these are the same answer. They're equivalent forms. So just because you don't see like your answer choice, you might have gotten 1 out of 2, but then maybe on the test question you see 50%, you have to know that those mean the same thing. So that's just some little stuff. Okay, so let's look at some examples. Okay, so the first one, if a coin is tossed twice, what's the probability of no tails? So the first thing we need to understand is what are all the possible solutions. So that's what I'm going to do. You can pause the video and you can make your little tree and then write them all out if you need to. But do that in 1, 2, 3. So here are your 4 possibilities. And then it wants to know if a coin is tossed, what's the probability of no tails? So the only one that gives you no tails is that one right there. So that would be 1 out of 4. Remember, that could look like this. It could be 25%. It could be 0.25. All of these mean the same thing. I usually just do it as a fraction. Alright, and then the last one. If a coin is tossed 4 times, what is the probability of getting no more than 1 head? Okay, so the first thing you have to do is find what are the possible outcomes. So pause the video and try that in 1, 2, 3. Alright, so here's my little tree. I got that there are 16 possible outcomes. And then you want no more than 1 head. So this one works, this one works, this one, this one, this one, and then everything else has more than 1 head. So that's 1, 2, 3, 4, 5 out of 16. That's the same thing as 5 to 16, or 31.25%, or 0.3125. They all mean the same thing. Okay, so let's look at some different rules. I think this can get a little confusing. So you can watch the video as many times as you need to, and you can ask me for help. So the addition rule number 1. It looks pretty complicated. This is how you write it in like notation form. So the probability of A or B is equal to the probability of A plus the probability of B. What this means, the probability of A or B is the probability of event A plus the probability of event B. I know that the notation is really hard to understand what's happening, so let's look at some examples. So a single 6-sided die is rolled once. What is the probability of rolling a 3 or a 6? Alright, so step 1, think about the possibilities. So we're talking about you could roll a 3 or you could roll a 6. The events. Are the events mutually exclusive, which means they can't happen at the same time? So yes, there's no way you could roll a 3 and a 6 at the same time because you're rolling one die. So now we're going to calculate the probability using the addition rule. So the probability of rolling a 3 would be 1 out of 6 because it's a 6-sided die. And then the probability of rolling a 6 would also be 1 out of 6 because it's a 6-sided die. So the probability rule says if I want to find the probability of A or B, I'll add them together. So 1 6 plus 1 6 is 2 6, which reduces to 1/3. So that's how you use the probability rule. Okay, so I want you to try both of these. Try them in 1, 2, 3. Alright, so if you don't understand what are the outcomes of rolling 2 dice, then you can watch the extra videos where I explain how to do that. But because you're in Math 4, and we did it in Math 2 and Math 3, I'm going to move on, because you have those videos to go back and look at. So the probability of rolling a 4 would be 1 out of 12. The probability of rolling a 5 would be 1 out of 9. So then I'm going to add those 2 probabilities together, and my final answer is going to be 7 out of 36. Okay, and then number 2, we're going to do the same way. So you try it in 1, 2, 3. So the probability of landing on green is 1/4. The probability of landing on purple is 1/4. So I add those 2 together. I get 2 out of 4, which reduces to 1/2. So that is my answer. Alright, so let's look at addition rule 2. So sometimes events aren't exclusive. They are dependent on each other, in which case we use addition rule 2. This means that these can happen at the same time. So here's the rule. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B at the same time. So in words, what this is saying, the probability of A or B when two events overlap, which means they can happen at the same time, they are not mutually exclusive. They can happen at the same time. So look at this example. In a math class of 28 students, 16 are boys and 12 are girls. On a unit test, 3 boys and 5 girls made an A. If a student is chosen at random from the class, what is the probability of choosing a girl or an A student? Okay, so here's the possibilities that can happen. So if you think about it. So you could do choose a girl. Alright, or you can choose an A student. Are the events mutually exclusive? No, because you can be a girl and an A student at the same time. So here's what we're going to have to do. We're going to calculate the probability. So the probability of being a girl would be 12 out of 28, which is 3 over 7. Alright, and then the probability of being an A student, here, let me change this. Let me say probability of being a girl. Probability A student would be 8 out of 28, which is 2/7. But you're overlapping because there are girls that are A students. So it's like if you did a Venn diagram, here are 12 that are girls. There are 8 that are A students, but you have girls that are A students also, so you're overlapping. So you got to figure out what your overlap is. So if 5 girls made an A, you're counting those twice. So here's what you do. I'm going to do 3 out of 7 because that's girls, plus 2 out of 7, that's my A students. But then I'm going to take away 5 out of 28 because that's from right here. 5 out of 28 are overlapping. So now when I put that all on my calculator, I get 15 out of 28, and that would be my final answer. So you can't count people twice if it's not mutually exclusive. Alright, so look at these examples. We're going to do the same thing. A single 6-sided die is rolled. What is the probability of rolling a number greater than 3 or an even number? So I want you to try that. Remember, you're going to add the two probabilities together, but then you're going to take away anything that overlaps. So think of that Venn diagram. Try that in 1, 2, 3. Okay, so probability that there's a number greater than 3. That's 3 out of 6 or 1/2, which is why I did that in purple and I circled it. Or probability it's an even number, so that's 3 out of 6, which is 1/2, I circled it. But then we got to take away greater than 3 and an even number at the same time, and that's 2 out of 6. So now I'm going to add the two probabilities, and I'm going to subtract the 2 out of 6, which is 1/3. Alright, so my final answer is 3 out of 6, which reduces to 2/3. That's my final answer. Okay. So now we're going to do number 2. So number 2 is a little harder sometimes for people to understand. I want you to try it, see what you can do in 1, 2, 3. Alright, so the probability of owning a skateboard is 0.37, and the probability of owning a bicycle is 0.81, and the probability of owning both is 0.36. So you're going to add the first two, and then you're going to subtract when they both do it together. So my final answer is 0.82. Alright, so if that didn't make sense, you can message me for help. Let's do some more. Alright, so here's the subtraction rule. This may be new, so this notation right here may be a little new for you. When you see that P apostrophe, that means not happening. It's so weird. Okay, so the formula is going to be 1 minus the probability that it does happen. But anytime you see that little apostrophe right there, that means the probability that not A is happening. Okay, so it looks really weird. It's pretty easy though. This is perhaps the simplest of the rules. You might want to think of it as the not rule. So for an event A, the probability of occurrence of A is probability of A. Then the probability that A will not occur is right there, the little P apostrophe A. Alright, so this is the most simple example. The probability of a biased coin landing head sides up is 0.74. So the probability of landing tails would be 1 minus 0.74. It does not get any easier than that. You put that in your calculator and you get 0.26. So it would look like this. The probability apostrophe A equals 0.26. So anytime you see that apostrophe, it means what's the probability of it not happening. So it's 1 minus the probability that it actually does happen. Kind of dumb. Alright, so here's an important one, the multiplication rule. And probably the one you're most familiar with. So it's already here in the box. So the probability that A and B happen is the probability of A times the probability of B. So let's look at this example. A drawer contains one sock of the following colors: red, green, yellow, orange, and blue. You reach into the sock drawer and choose one sock without looking. You replace the sock and then choose another sock. What is the probability that you will choose a blue sock both times? So, possibility, what are the possible outcomes? That you choose blue both times. That's what you're doing. So the events. Are the events independent? Which means they are not dependent on each other. So yes. So just because you choose a blue sock the first time has no bearing on whether you're going to choose it the second time. So they're equally likely. Alright, so here's what we do. So the possibility of choosing a blue sock the first time would be 1 out of 5, because there's 1 out of 5 choices. And then the probability of choosing the blue sock the second time would be 1 out of 5. So the probability that they both happen would be 1 out of 5 times 1 out of 5. Put that in your calculator, you get 1 out of 25. That's your answer. Okay, so let me just go into detail about what I mean when I say an independent and a dependent event. So two events are independent of each other when the probability of one event occurs in no way affects the probability of the other event. Examples: roll of a dice, flip of a coin, where a spinner lands. So a dependent event would be two events are dependent on each other when the outcome of one event affects the probability of the other event occurring. Example: if I pick a marble out and I don't put it back and then I pick a second marble out, the bottom number is going to change on the fraction is what's going to happen. Alright, so let's look at the second multiplication rule, and this is a little more challenging. So the probability of A and B occurring is equal to the probability of A times the probability of B given A has happened. So it's not going to be out of a total number of outcomes because you're being more specific. So if that doesn't make sense, when two events are dependent on each other, the probability of B occurring is the probability of B given that A happened. Let's look at the example before you freak out. Suppose you take two cards from a standard pack of cards one after another without replacing the first card. That's what makes it dependent. What is the probability that the first card is an ace and the second card is a 2? Alright, so here are the possibilities that could happen. So first ace, second 2. Are the events independent? No, because they're definitely going to change. So we're going to calculate the probability using the multiplication rule. So the probability of A, that means the first card being an A, is going to be equal to 4 out of 52, or 1 out of 13. If you don't understand where I got those numbers, go watch some previous videos where I explain it. Then, the probability that B occurs knowing that A happened is going to look like this. So I don't have 52 cards any longer because one of them I've taken out and it was an ace. I now have 51 cards. Out of those 51 cards, 4 of them could be a 2. Alright, so the probability of A and B would be 1 out of 13. That's the probability of an ace. And then 4 out of 51. So notice what happened. In the first event, you had a bottom number of 52. In the second event, you had a bottom number of 51. That's how I know that these are dependent events. So when I get this, I get 4 out of 663. That's my final answer. Alright, so let's do these 2 examples. You can try both of them if you want to. You can try them in 1, 2, 3. Alright, so for the first example, that is an independent event. Because choosing a queen and then choosing an 8 and replacing has nothing to do with each other. So the probability of choosing a queen is 1 out of 13. The probability of choosing an 8 is 1 out of 13. I multiply them together, I get 1 out of 169. The second one is dependent. It's dependent because you do not put it back in the bag. So that's how you know to use multiplication rule 2. The probability of picking a yellow is 2 out of 11. You did not put the marble back into the bag. So now out of 10, you have 5. Or you could reduce that to 1/2. So now when I multiply these 2 together, I get 1 out of 11. So the first example was using multiplication rule 1 because it was independent. The second example was using multiplication rule 2 because it was dependent. Alright, let me know if you have any questions. Go watch the extra videos if you need extra help. And we'll see what we can do. Alright.